Good morning, everyone. Good with sound? Yeah. So, talking about cloud in space. And before I dive in, I wanted to give you the punchline for this talk. The punchline is the past 25, 30 years since the internet was invented, we've culminated in what Sid just talked about, wonderfully about the advancement in compute services and cloud services at a global scale. And we have heterogeneous communication between my phone in my pocket to potential data storage in Hyderabad, right, for particular use cases. In the next 25 to 30 years, all that infrastructure and capability is going to be replicated, migrated, and proliferated in space. And that's a huge opportunity in the next 30 years. It's a really exciting time to be alive, let me tell you. So that said, I want to give you a quick intro to Axiom and what we're doing, and then slowly bring you to the aspects of how we're collaborating with AWS and on-orbit cloud capabilities. So our vision is a thriving home in space for everyone, anywhere. And our mission is to create a space station in space that improves life on Earth and extends economic opportunities in space for everyone, everywhere. And that's our mission. And we are well underway in our mission. So by the end of 2025, we will have our first module up on the ISS. So that'll be history. So it'll be humankind's first commercial space station module attached to the ISS. So whereas the previous infrastructure was government-owned, government-operated, government-developed, the future of space stations will be privately owned, privately operated, and constructed. We have modules thereafter for the next few years until the end of the decade. The anticipated detachment from the ISS by the end of this decade when the ISS starts to retire. And why are we doing this? We're living at a juncture of economic renaissance in space. So just the past few years, we've had dozens of private citizens go to space, either low Earth orbit or the upper edges of our atmosphere at the boundary of space. And that's going to continue, it's going to grow. And Axiom just did its first private astronaut mission with 4 private citizens going to the ISS just this April. And this path is laying the foundations for not just having people visit space for short durations of time, but the foundations for having people live and work in space in the dozens, hundreds, and someday, I think in our lifetime, in the thousands. And all these use cases you see up there is the reason why. There's a tremendous amount of economic opportunity that is synergistic with population growth in space. So let's talk about advanced pharmaceuticals. The ISS has proven in the past 20 years that the lack of gravity in space actually is very beneficial to making new drugs, new biotechnology. The physics is different, so you can make things that are potentially far more advanced and better than you could on the ground. The same with advanced materials. There's applications in making bigger structures, better satellites, better spacecraft in space because of no gravity. There's applications in cloud services that I'll be talking about as well. So the point here is that this entire spectrum of economic opportunity that will go hand in hand with hundreds of people living and working in space is all underpinned by common technological need, and that need is data infrastructure. And that's why we're partnered and privileged to partnering with AWS on starting to lay the foundation for what proliferated space-based data infrastructure looks like. And so in April, as part of Axiom 1 mission to the ISS, we deployed a snow cone on the ISS. As Sid mentioned, snow cone is a very resilient, compact device that can accomplish a variety of workloads. We actually put it to test. We ran some machine learning algorithms to filter images taken on the ISS and help reduce the latency and the workload on the ground for having to go through the filtering of those images. And it worked. Today, and actually as part of the Axiom mission, we are demonstrating additional use cases that will leverage Snow capabilities and edge capabilities in space. On the left is a bioexperiment where our astronauts looked at cells undergoing simulated cancerous growth to see how the lack of gravity could affect that growth, either slowing it down or changing it, so it can give us insights in discovering new ways to attack cancer that we otherwise couldn't do because of gravity on the ground. And on the right, we have our astronauts from Canada, Mark Pathy, that's demonstrating the world's first holoportation demonstration between space and the ground. And so if you think about astronauts going to Mars, 6 months one-way trip, if one of them gets sick, you can't depend on Earth to have them come back to normal. So these kinds of demonstrations, entangled with on-orbit edge capabilities, are key to maintaining human life as we expand in the solar system. I love this quote. It's by Lisa Costa, Chief Technology and Innovation Officer for the Space Force, the US Space Force. She talks about the need to grow the infrastructure in space to support what I just talked about, the replication and proliferation of terrestrial-grade networking, data transport, data storage, data compute, and cloud service in space. Because as we grow our footprint, as we grow the needs, as we grow our propensity for space exploration, as we talk about growing economic opportunity, all that will require more and more infrastructure in space to support all that. And this is what that quote is about. At Axiom, we're would like to take a leadership position in pushing all the elements required to start growing data infrastructure in space. So we're working with 2 particular companies shown here, one for the demonstration of high bandwidth communications between a space station and satellite assets to prove that you can push data in a heterogeneous way between assets in space. And also, last summer, we worked with a company in the UK to demonstrate the world's first quantum encrypted communications link between the ground, space, and back again. Cybersecurity is going to be a big thing in space, both for commercial space exploration and national security purposes. And going back to Sid's slide about the use cases and why doing things on the edge why is it important to do things on the edge? And you talk about low latency, you talk about on-prem processing, and you talk about residency. And all those things apply to space. Low latency. Right now, our networks are quite slow in space. So adding edge compute to those network nodes actually helps significantly reduce the latency of getting data back to the ground or back to where it's needed. On-prem data processing, again, the same thing. Let's think about a spacecraft traveling to Mars. It sees solar flare or radiation particles coming at it. You need that data processing on-prem to tell the crew to go hide in the shielded area because there's a solar storm coming or something like that. Right? So there's definitely applications in space where the 3 tiers of why you need edge compute make sense in terms of use cases. Which brings me to the future, and this is my last slide. Our CEO talks about hundreds of people living and working in the next generation Axiom station. It's no longer a station, it's a city, orbiting city in space, and that's depicted by the artistic representation on the far right. And our visions for that by 2040, we believe it's realistic, and that's what we're doing today with sending private astronauts, building a small space station at first, module by module by module, because the culmination is to address all those economic opportunities I talked about a few slides ago and conduct them as part of a growing and sustainable human population in low Earth orbit. We're also working with NASA on next-generation spacesuits, because part of that vision is growing human population in stellar space and the moon, and eventually Mars. And thinking about how all this interplays with data, right, it comes back down to the economics and the economic opportunity. As human population grows in space, to address all those economic opportunities, commensurate growth of data needs and commensurate growth of the data infrastructure required to support those data needs of that growing population addressing economic opportunity. It's all a feedback. So that said, we're very excited about working in AWS. I think our visions are very synergistic. Thank you for your time.